Physics, Part 59. It is very important to include direction in the definition of work done. A car can be pushed horizontally quite easily, but if the car is to be lifted off its wheels, much more work has to be done, and a machine such as a car jack is used. When a force moves its point of application in the direction of the force does work, and the work done by the force is said to be positive. Conversely, if the direction of the force is opposite to the direction of the movement, work is done on the force. The work done is then said to be negative. This is illustrated in the figure. An alternative name for the distance moved in a particular direction is displacement. Displacement is a vector quantity, as is force. However, work done has no direction, only size and scalar quantity. It is measured in joules. When a force of 1 Newton moves its points of application by 1 meter in the direction of the force, 1 joule of work is done. The work done in joules is force in newtons. The work done in joules is equal to work force in newtons, distance moved in meters in the direction of the force. It follows that a joule J may be said to be Newton meter M and M. If the force and the displacement are not both in the same direction, then the component of the force in the direction of the displacement must be found. Consider force F acting along the line at an angle of theta to the displacement, as shown in the figure. The component of the force along the direction of the displacement is F cos theta. Work done for displacement x is equal to F cos theta into x Fx cos theta. Note that the component of F sin theta is the force. If the force is at right, if the force is at right angles to the displacement, since there is no displacement in the direction of this component, no work is done. Well, we see it in the figure, the useful work done by the work done by the small tugboat is found using the component of the tension in the rope along the direction of the motion of the ship. Example: a child tows a toy by means of a string, as shown in the figure. The tension in the string is 1.5 Newton and the string makes an angle of 25 degree. Let me re-explain it. The tension on the string is 1.5 Newton and the string makes an angle of 25 degree with the horizontal. Calculate the work done in the moving the toy horizontally through a distance of 265 centimeter. Work done is equal to horizontal component of tension into distance moved, 1.5 cos 25 into 265 over 100, which is equal to 3.63. Now it's your turn. Number 1, a box weighs 45 Newton. Calculate the work done in lifting the box through a vertical height. A 4.0 meter, B 67 centimeter. Number 2, a force of 36 Newton acts at an angle of 55 degree to the vertical. The force moves its point to the application by 64 cm in the direction of the force. Calculate the work done by A, the horizontal component of the force. be the vertical component of the force.